Hello, this is Mason Haggerty with question 6.21 from the Fundamentals of Heat and Mass Transfer by Bergman, 8th edition. So this question states, consider the laminar boundary layer flow over a flat plate. For identical flow conditions, determine the entries not shown in the table below using the fact that delta over delta T equals Prandtl number to the n. The pressure is P equals 1 atmosphere for each case. So in the table we can see that there are 4 fluids: air, water in its liquid state, engine oil, and an unknown fluid. We know that the temperatures for air and water are 300 and 350 Kelvin respectively, and we have the delta over delta T ratio for the air, the engine oil, and the unknown fluid, and it gives us the hint to see appendices A.4 through A.6. This is not really a hint, this is pretty necessary because the tables have all of the data that you'll be using. So first, I just quickly jotted down some notes again that delta over delta T is equal to the Prandtl number to the n, and because we know that the flow conditions are identical, we can assume that the n will be the same, so we'll have to find that. I also noted again that pressure equals 1 atmosphere for all of these, and then I just filled in the table and marked out the 4 missing values just to make it clear what I'll be looking for in this question. So to begin, I'm looking at table A4, and I'm looking at air at 300 Kelvin at 1 atmosphere gives a Prandtl number of 0.707, and because we know that delta over delta T is equal to Prandtl number to the n, we can know that n is equal to the log base Prandtl number of delta over delta T. From the table, we have that delta over delta T is 0.89 for the air condition, again at 300 Kelvin and 1 atmosphere, and since we know that the Prandtl number is 0.707, again from table A4, we can find that n is equal to 0.3361, and this is the n that we'll be using moving forward. Next, we move to table A6, where we're looking at water at 350 degrees Kelvin and 1 atmosphere. This gives us a Prandtl number of 2.29. Because for this table entry, we're trying to find the delta over delta T. We know that that is equal to the Prandtl to the n, and now that we have Prandtl and n, we can just solve it, and we get that the delta over delta T for this situation with water, again liquid, is 1.3211. Next, we're going to move back to table A5, and we're looking at engine oil. I just assumed unused, but that's just an assumption I made. And we know that it's at, we have the ratio of delta over delta T, and since we know that that again is Prandtl to the n, we can know that the Prandtl number is delta over delta T to the root n, which again we know. That gives us that the Prandtl number is 3,413.8, which looking at the table is close enough to 3,400, and so we're assuming that the T is basically equal to 310 Kelvin. That fills in that missing value. Finally, for the unknown fluid, we're going to look at a couple different tables. We know that the Prandtl number will be equal to delta over delta T to the root of n, or to the nth root. And from this, again, we are given that the delta over delta T is 45.3. We find that the Prandtl number will be 84,605.2. So as you look through these tables, you'll notice that there is only one value that gets anywhere close to that high, and that is glycerin. And on the table, we can see that glycerin has a entry at 85,000 for its Prandtl number, which 85,000 is close enough to 84,605.2. And so we know that this missing fluid is glycerin at 273 Kelvin. And with that, we have all of the missing entries from the table, so let's fill it in. And for my use, I had blue was given info and green was solved for. So our 4 fluids are air at 300 Kelvin with a delta over delta T of 0.89, water at 350 Kelvin with delta over delta T found to be 1.3211, engine oil unused at 310 Kelvin with a delta over delta T given at 15.4, and finally glycerin as our mystery fluid with a temperature of 273 Kelvin with a delta over delta T of 45.3. And that wraps up this question, so thank you.